Okay, good day, viewers. I'm a wonderful student. How the concept, the topic for today is the concept of isotopy and isotopes. And the objective of the lesson is stated below. One, to differentiate between isotopy and isotopes concepts. Two, to give examples of elements exhibiting isotopy and state their isotopes. The third one is to be able to solve some simple calculations. Our previous knowledge shows that we are familiar with atomic number and mass numbers. We need to just make a quick recap of this as we're going to be in need of it in our lesson. So atomic number is the number of protons present in the nucleus of an atom, while mass number is the sum of neutron number and uh, proton number that are present in the nucleus of an atom. So that gives us the weight or the mass of the the element. Okay, so what then is isotopy? It's a phenomenon whereby an element exists in two or more forms, having the same atomic number but different mass number. Okay. How does this now go on with the concept of isotopes? What then is isotopes? Let's look at what an isotope is. These are atoms of the same element with the same atomic number but different mass number due to change in their neutrons. So if you look at the concept of isotopy and isotopes, the first one, the other one, I mean, isotopy, it's a process whereby an element exists in two or more forms. Okay, I'm going to be using this analogy to have that better. It's just like I have a particular person, this is someone here. However, the way this particular object is existing is that it's existing in two or more forms. Okay, so maybe it's existing as is existing as something else because it's now here. It's existing as something here. It's existing as something here, and so it's like this and like this. Also, but one thing that will unite the fragment in which it is existing from, mm, we can refer to it as that it's going to have the same atomic number, which we have, which we call Z, and the same mass number Z, the same atomic number Z, but different mass number A. That's exactly what we are saying, the same mass number A. So now, the process whereby this particular thing is existing in these two or more forms, we call it isotopy. Now, the fragment in which it is existing from, the atoms, are what is called isotopes. Isotopes. Okay. Then let's move on to the way to represent these isotopes of an element. Okay, this is exactly what I'm trying to explain here. We have an X here representing the symbol of an element. Then we have A representing mass number, while Z is representing the atomic number. So when we have the symbol of an element that is attached to it, mass number and atomic number, we refer to it, we call it nuclear symbol. And that is used in chemistry to represent the isotopes of an element. Let's look at a very good example. We have chlorine, which has two naturally occurring isotopes with nuclear symbol chlorine 35 and 17 atomic number. The second one is chlorine 37 mass number and atomic number 17. Okay, we usually call it by the name of the element and their mass number because that's the weight. Their weight determines the identity also together with their name. So that's why we say the chlorine 35 and the second one is chlorine 37. So this is the nuclear symbol. The atomic numbers are the same while we have different mass numbers. So according to our calculations, we can be able to see that there will be changes in the neutrons of the isotopes of the element of chlorine. Another good example here is hydrogen, which has three isotopes with the following nuclear symbol. We have the first one, which is called protium, with nuclear symbol H11. Deuterium is the second one, called heavy water, which has a nuclear symbol H21. And the third one, tritium, with the nuclear symbol 3131. That's the third one. Those are the three isotopes of elements hydrogen, elemental hydrogen. Okay, we have other elements that also exhibit the process of the concept of isotopy. Some of other examples include oxygen, carbon, and copper. So I would love you, my dear student, to please find out the concept of the isotopes of those elements I made mention of. Okay, let's proceed. We have some things we need to take note of that will be of use of great help to us in our calculations. The first one is atomic number. Z equals number of protons present in the nucleus of of an element. You need to take note of that. And then we have the second one, which is mass number A itself, which is the sum of number of protons plus the number of neutrons. And the third one here is the number of neutrons, which equals mass number minus atomic number. No, we can actually deduce number three equation from number two. Okay, for students that are good very well in their mathematics. And the fourth one, number of proton equals number of electrons. That is necessary for us to take note of, as it's going to be of great help to us in our calculation. Okay, let's look at this table below. There's a question. We have to complete the table below. We have the element Wx, W, X, and Z here. They have their mass number and their atomic number. So we're just also fill in the gap. So I'll just give you 30 seconds to do that. For W, what's the number of protons? What's the number of neutrons? For X, what's the number of, what's the mass number there? Then what's the number of neutrons? Okay, for Y, we have to supply the mass number, number of protons, number of neutrons. It's very simple. Just apply the principles I gave you earlier in the first, in this previous slide. And this is it. Okay, right now I want to believe you have solved it. Okay, these are exactly what we are thinking. Okay, so then let's look at it here. Can we see? Does it really match with your own? Oh, wonderful. That's good. So now that we have been able to do this, let's exactly what we need to take note of regards the concept of isotopy and isotopes. Okay, so let's evaluate ourselves. Let's differentiate between isotopy and isotopes. Let's give two other examples of elements that exhibit the concept of isotope and state the isotopes of those elements that are listed. So those elements that are listed, I gave you some of them: carbon, oxygen, copper. Mm. I'll give you three now additional. So find out the isotopes. Mm, That's going to be, we're going to be looking at that in our next lesson. And the final thing we'll be looking at in our next lesson is the calculation, how to apply isotopic concept in determining the relative atomic mass of an element. But on this note, we draw the curtains of this lesson. Thank you for watching. You can please subscribe to my channel always. Thank you and God bless.